change consensus protocols on a running chain. This is polymorphic consensus. One chain, multiple consensus protocols. And in this video, you will see a demo of polymorphic consensus. We will change from a RAFT-like protocol to a Tendermint-like protocol through the governance process. So in today's case, we will have multiple consensus protocols, but one at a time. In a blockchain, the consensus mechanism or protocol can be immutable, for example, Bitcoin and Ethereum. The mechanism can be parametric, and all Cosmos SDK chains are of this type, also most L2 protocols. It can be polymorphic, and Mythos is the only chain of this type, and today you will see the first demo of a polymorphic chain. Or it can be mixed, polymorphic and parametric. And Mythos is the only chain of this type because it is built on top of the Cosmos SDK, but modularized with WebAssembly contracts. In the previous video, I showed you a first consensus protocol change. At that time, we were changing from a RAFT-based protocol to another RAFT-based protocol. And this time, you will see how the block proposers change when the chain switches from RAFT to Tendermint. And both RAFT and Tendermint are implemented as smart contracts. So, the consensus protocols are not hard-coded into the chain. At any point in time, you can actually create another consensus protocol and deploy it as a normal contract on the chain, and then propose it as a new consensus protocol through governance. Or you can go back to a previous consensus protocol. Our consensus contracts are built as finite state machines, and this is the RAFT consensus that I explained in detail in a previous video. And this is the Tendermint consensus that I will explain in a future video. And I showed you that we have built a finite state machine interpreter. So our consensus protocols are implemented as finite state machine diagrams. And not only that, but these diagrams produce a JSON configuration that is directly interpreted by the chain through an interpreter contract. So the configuration is actually treated as smart contract code. This is a local Mythos chain that uses the RAFT consensus now. And we have a leader node here that proposes blocks, and we can see blocks being finalized. It proposes blocks with a heartbeat of 5,000 milliseconds. So the block production speed is around 5-6 seconds. And here we have the follower node. And the follower node validates the blocks and then commits them after the leader determines that the majority of nodes have received the block. So there is only one block proposer, and it is this node, the leader. And we can see the explorer, and we see that there is only one proposer named node 1. So I will deploy another consensus contract on the chain with Tendermint consensus. So for this, I will make a governance proposal to assign the contract the consensus role, and then we will watch the consensus change process. And I have a dApp here that allows us to deploy and interact with various types of smart contracts on Mythos, from Solidity EVM contracts to JavaScript and to state machine contracts. And I have a state machine configuration here for Tendermint. And along with this definition, we also give a library with custom functions as dependency. So we will replace this and have both the dependency on the state machine interpreter and also on this library with custom functions for the Tendermint consensus. So now we upload this as a contract, and we get the receipt here. We get a code ID of 26. We can also take this transaction hash and search for it in the Explorer, and we see it is a message store code, Cosmos message, and we again see the code ID here, which is 26. So now we will instantiate this contract. We need some instantiation data. And this is a JSON with the initial values that the state machine expects. And we can also see here a round timeout of 10,000 milliseconds. So we will have a block time of 11 seconds. And now I'm going to take this hex string and transform it to base 64. So let's instantiate this. We get a transaction receipt, and we will take the contract address from the events of this transaction. So this is our governance proposal, and let's copy this contract address. So we are registering a new role. Well, it's not a new role, but on the consensus role, we are registering a new contract that has this label and this contract address with a title and description for the governance proposal. So now we can get this transaction hash, and actually we should be able to see in governance, we can see now our proposal. And let's also vote for this proposal. So now we can refresh, and we have a vote here. We can also vote with the other node. And now we have 100%. So what will happen now is that the testnet takes the testnet proposals take 2 minutes to finalize. So after 2 minutes are passed, we should see a consensus change on both of the nodes. And first, we will see it in the leader node and then in the follower node. And what happens is that the consensus contract is the one that proposes and finalizes blocks. So after it finalizes the block where the governance proposal has been tallied and has been finalized, it checks for the consensus contract for the block events where we can see the consensus contract change. So let's go here and actually see the blocks. And still node 1 is finalizing and proposing blocks. And we already see Tendermint, the Tendermint contract working. So, and it is working in both nodes. And we see both nodes now proposing, node 0 and node 1. Let's do a refresh. So let's look at the logs in more detail. So here we still have the old consensus, the RAFT consensus, working and finalizing blocks. And then here we have started migrating storage for the new consensus contract with this address. Because it was deployed as a normal contract with a core consensus type storage, we now need to migrate the storage of that contract to single consensus, because this is a non-deterministic contract. After we migrate that storage, the governance module finalizes the proposal, and then after the block is finalized, the current consensus, which is RAFT, has detected that there was a consensus change because it looked in the block events. So now it is setting up the new consensus contract at this address, and the previous contract was at this address. And what happens is it copies over some of the data that the new consensus contract needs, like node IPs, validator data, and I have these logs here so you can see in detail mempool data if there is any, and so on. So now the next consensus contract has been set, and we are stopping the current consensus contract. Only now we have finalized the block and have committed all the state that was changed. And now what happens is we are still in the current consensus contract. So now we are sending the message, the event, the state machine event, to the new consensus contract for it to start itself. And here we are still, actually we are in the new contract. We see here Tendermint 0. And we have the confirmation that it was started, and we are still in the old consensus contract here because there are still some processes that go on, but they should be stopped because the state has changed, so we can no longer run these processes. And now the new Tendermint contract starts from here, and it receives a block proposal, which means this other node is the first node that actually proposed a block in the new consensus. So let's see here. This is the first block proposal done under the new consensus with height 170, and from here on both nodes are taking turns and proposing blocks. And the chain is still running here and in the Explorer also. You have witnessed a consensus protocol change on a live running chain by governance. In future videos, you will see more consensus protocols implemented as smart contracts and much more.